Hello friends, konnichiwa. My name is Asma and welcome to day 1 of the machine learning bootcamp for our common sentiment analysis. Okay, in this video we are going to learn and understand on how to do pre-processing, how to understand the data and we need to know when we need pre-processing of each type and how to use statistics to pre-process. Okay, so this video will be very much helpful for those who have not yet pre-process their data. Okay, this is basically about pre-processing. Also, to be make sure, I will not be doing pre-process of text here for our comment here. That will be for our very next video. Okay, so in this we are only be dealing with the general process of any tabular data set. Okay, and I will be assuming you have merged all files, so finally you will be having one train.csv. You will be having train.csv, test.csv and submission.csv for this bootcamp. Okay, so I assume you will be finally merging all the files you have get here. Okay, so now what is processing? Processing means preparing raw data so that the machine learning model can learn it properly. So for our machine learning model, which needs basically clean numeric and structured data, so the raw data we can directly feed it. Okay, the raw data is, or the real world data is very much messy, inconsistent, noisy and imbalanced. Okay, so we don't feed our models directly with raw data, and that's where the pre-processing come. So the whole pre-processing pipeline is of 7 steps here. Okay, only 7 steps, not under 7 or not above these 7 here. Okay, only 7 steps, not 6, not 8, but with the whole 7 steps your whole pre-processing start and ends. Okay, and also I'll be not be doing pre-processing or comments here. Okay, it will be for my next video, so I'll be skipping it for now, as I have already told you. Okay, in this video we are going to see only our tabular data set. The pre-processing go from left to right, first starting with handling duplicates, then handling our imbalance, where basically our train test split occurs, and then we have handling our non-numeric or categorical values here, then we have our handling null or empty values, then our handling outliers, then in our 6th position we have our feature scaling, and then finally we have our feature engineering. Okay, so in the 7th step the whole pre-processing occurs, and here each step requires some assumptions and some requirements. Okay, so now for our first pre-processing is to we have to check here duplicates here or not. Okay, so we check by our df.duplicated, or basically by seeing all the rows under df.duplicated. Okay, and if both are 0 you could skip this step. Okay, it is not needed. So if you will see here, I have imported 3 dataset here, and here for checking the duplicates I will be using my duplicated function, where when I will printing for my def value, you would see here that my def value don't have any duplicate function here. Okay, so you will get it np.int4 for our movie. You will be seeing that there is 473 values that is missing here. Okay, and this is the duplicate value, we have to remove it. Okay, also for our empty here, like duplicated, you could make sure by using df bracket df.duplicate, where everything will be empty here. Okay, so you will not be seeing any rows here. Okay, for our movies.head, you could see here that there are many variables here from movies here, etc., and these were somewhere we have duplicates. So the duplicates is the value where the 2 or more rows represent the same real world event or our entity. Okay, here one thing you must understand is duplicate row doesn't mean we have duplicate values, and duplicate IDs doesn't mean we have duplicate records. Okay, in some data here duplicate makes sense here. Okay, for example, here the same customer entered twice. Okay, we would not be seeing it duplicate here, but here when the same transaction logged in twice, we would considering it as duplicate here. Third is that same image repeated it in database, we would say it's a duplicate here. Okay, so you would see that it depends on the context here. not on whether there was an actual duplicate or not. So now after this, the first thing we must understand is that why is the value duplicate here is the most important question before handling. Okay, so first it may be data entry errors. Okay, so some record entered twice manually, so here it will be pure duplicate, so it will be very safe to remove here. Okay, second thing it may occur is that we may have multiple record per entity. Okay, so for example here we have student id, subjects, marks, and here we have logged the entries of the student. Okay, you would clearly see here the student id 101 have the two subject, marks different here. Okay, so basically we would say that they are not duplicates, but removing them would destroy information. Okay, so we'll be doing aggregate here. Here it have duplicate, but here the duplicate have meaning here. Okay, now the third type is the time series or log data, where basically you see here that I have user id, timestamp, and action here. Okay, so you say that one user id logged in twice here, and that is logged in the database here. So here it may not be duplicate depending on the context here. Okay, so in duplicate, context matters heavily. This you must understand. As a data scientist, you must always check and decide by seeing the duplicated here. Okay, so like if I'll be going to my movies here where we got the duplicate here, we'll be printing the duplicates, and here you would see the whole the duplicate rows here. Okay, so here for the first 5 you could see here that it's an mighty beam movies where basically it had been duplicate almost like 5 times here. Okay, so like you have to use your data analytical skills, and you must decide is this duplicate an error or a real repeated observation. Okay, if it was an error, like here you see that here the mighty beam is repeated multiple times here with very little change, so we could clearly say that it may be an error during data collection, etc. Okay, and here you could say other duplicate rows through here. Okay, so basically if it was an error, you could use df drop duplicates, where the subset you will take is id and you will be keeping the first file only here. Okay, so we will be doing this by drop duplicate function with our subset and our keep equals to first, last, or our false here. Okay, so if it is first, it will be not be dropping the first value here, and if we'll be printing now the movie though duplicated, you will see that there is no duplicate finally here. Okay, and everything will be false here in our final statement, and the length had also been contracted some because we have removed some duplicates here. Okay, and now if you think that there was not an error, then you could use the aggregate function here to aggregate all the values for the data set here. Okay, so if you will be using my students function here, you see that I have some student data with duplicates value. Okay, so if you will be printing here 9 here to print all the values, you could see here that I have two times Divya, 2 type Arnab, etc. here. Okay, so by using df.group by, we basically will be creating a new file where we will be aggregating their mark, age, city, etc. Okay, so we could do this easily by using our students dot group by, then with our student id here, and then we will be using as index equals to full, then we will be aggregating all. So the physics mark will be max, then the chemistry marks 2, then the maths mark 2, and then the exam day should be false, class should be false, and the student id should be false here. Okay, so when now I'll be printing the head here, you will be seeing that here it should be index equals to false, and here you will be seeing that there will be only one Ananya, Divya, etc. Okay, if you will be printing till the 9 part, you will be seeing that there is only 5, there will be only 5 students, and others are just merged here. Okay, directly. So this is basically how you used your group by and aggregate to remove duplicates and take the sum of the whole rows here. Okay, here now we have our imbalance dataset, and first thing is that if you are using classification dataset here, okay, if it is in classification dataset, if you will be printing for your the target variable here, you see some imbalance here, okay. So if you will be going to the popularity, you will see that the variables it could take is popular and unpopular. Then if you will be doing value counts here, so the df dot value counts, if we put normalize equals to true, you will see that the classes are slightly imbalanced here, okay. So likely some part of the class slightly dominates than the other here, okay. So if one class equals to 1 to 0 20% here, it is usually called unbalanced here, and at that time we generally don't skip the data set here. But here since we have only between here 55 44, we will be skipping it here. But if it was between 0 to 20%, you should always use our handling imbalance here, okay. So when one class has much more samples than the other class, like our 950 samples and then class 150 sample, you will see that it's 95% versus 5%, okay. So if you are training on model here, you will get 95% score, but your model will actually be learning only the class 0 sample, okay. So the real level data is really balanced, like basically your fraud detection, disease detection, span detection, or medical abnormality detection, okay. In this detection, the rare events are naturally imbalanced and dominant to one class here, okay. So to solve this problem, you always use Stratify during our train test split here, okay. So we first import, and then inside the train test split we always do Stratify equals to y, okay. So we import everything normally, and then in our train test split we use our Stratify equals to y and random string equals to 48 to basically stratify the whole column here, okay. So here it should be random state here, okay. So random state here equals to 42, and in this way we basically stratify. So basically the train and validation will be differentiated into equal size here, okay. So in this way we solve our train test split problem for our imbalance test. Now for our SMOTE, which creates synthetic minority samples here, okay. So we import it from imbalance dot oversampling and we initialize it. Then we use our X train and Y train and use our SMOTE to fit and resample the data size here. So in this way we will be getting the sample size with the same amount of X and Y data set here, okay. So you could use it only when the one class is overly dominant and another class is 1 to 10% data size only. So our SMOTE is used for our creating synthetic minority samples, and we'll be basically fitting our model on these samples here to overcome the unbalanced classification classes here, okay. So with this we do our SMOTE here for our imbalanced data set. Then next we have our categorical data handling. You could check this by using df dot d types here, okay. So when you will be printing this, you would be seeing here int objects, float, etc. values, and here if you are seeing the objects or the category column, then you could say that you need your categorical values, okay. For movies also we have the same types here. We have your object, float, etc., okay. So if there is one object or category column, then this thing is needed, okay. If it is all numeric, you may skip this option, okay. So category data handling means non-numerical values representing categories, okay. It is because of labels, location, types, status, etc., okay. So and why it is important? It is because machine don't understand strings, it understand numbers, okay. So model work with numbers only. So when model says Delhi, it is meaningless, as the computer needs a numeric representation of the categorical column, okay. It is because the model do mathematics like distance calculation, gradient, etc., okay, and mail into 3 basically will not be support. Now there are two types of categorical variable. First we have is nominal variable, which have no ranking or order associated with it, like red, blue, green, etc. And then we have ordinal, which have order associated with it, like our low, medium, high, poor, good, excellent, okay. There is an order in our ordinal. Now how we handle that? If it is a nominal, we use our label encoding to change our categorical to numbers here. Okay, so for our label encoder we use for our nominal category, and for ordinal encoder we use our ordinal encoder to get the category to numbers here. Okay, so basically the encoder change category to numbers, which we could find from sklearn or pre-processing. Here first we define encoder and then we feed the transfer in our training set. Okay, so if we'll going to our code here, we import our label encoder, then we define it, and for category we get select d types, where we include our object and category to be seen. Then we define our feed the transform and run it inside the for loop for our categories here. So when we will be running it, you see here that there's only int and float here. Okay, so by this we encode our categorical column to numbers here. Okay, so we change each category into numbers. We use from the sklearn of pre-processing. Then I define the encoder type based on nominal or the ordinal. Then I feed the transform for each column here. Okay, so then this is how the encoder works to change categorical into numerical. Now next we have is missing data handling here. Okay, so we could check it by using df dot is null bracket is sum here. Okay, so if it is coming to be 0, then everything is fine. Otherwise you had to basically handle the null types. Okay, so here in my df I could see many here. So a null or missing value means the value which was not recorded, or the value doesn't exist, or the value exists but is unknown here. Okay, here null doesn't mean empty string or it is 0 here. Okay, one thing you must understand it. Then the example can be age not provided, salary, then sensory failure, or data loss during collection. Okay, so why we got the missing value? So there could be 4 possible reasons. First is missing completed at random. In this basically we get random missing values. Okay, so it could be due to random sensor failure or accidental deletion, etc. Okay, it is very safe to remove or impute here. Okay, then we have here missing at random, where basically the salary missing more for young people or medical test skip for healthy patients. Okay, here it is somewhat at random, and the null value represent a small feature here. Okay, it requires smart imputation, and if the imputation is not correct, it could easily intrude bias here. Now the next we have MNAR, which is missing not at random. Here basically you could see a pattern here, like people with very high salary hide it, or patient with severe illness keep it. Okay, so we can't remove null or use imputation here, which will cause here wrong conclusions. Okay, because sometimes missing itself is an information here. Okay, you could clearly see a pattern in this type of data. Okay, in your MNAR, so this must be handled very carefully. So now how should we handle? First is we could use directly our imputer for the columns that have the null values here. Okay, so if you would see it clearly here, you could easily classify the MNAR and the MCAR directly here. For missing completely random could be language, country, language, etc. And for our MNAR, it would be budget, gross annual income, worldwide gross income, which could be hidden on purpose. Okay, so it could be on our MNAR list here. Okay, so this is what MCR and MNAR actually is, where basically the budget etc could be hidden by the influential people to stop the negative 5 of the movies here. So to impute here, we use our sklearn dot impute, and we import our simple imputer to solve this problem. So for our imputer to work, we must make sure we import our simple imputer, and for numerical category we always use our median, and for categorical we generally use our most frequent here. Okay, so for our data types here, we get by our df select data types, where we first include and exclude for our numerical. Then for each category we use our simple imputer on each category, and we select our most frequent for our categorical, and then we input and feed transport the categorical column to get the final here. And then finally, if we'll check here is null, you will see that everything is null here. Okay, finally, so this is basically how we impute our categorical value. Okay, for numerical you must check histogram and then decide if it is symmetry. You could use mean. If it is skew outliers, you could use median. And for non-linear, you use our KNN imputer, which you get from sklearn impute only. Okay, for KNN, make sure the data is scale and the data is small here. Okay, and also feed transformer train and transformer validation. So like if it is MNAR, then you must add a missing feature as a feature. Okay, so basically we create a missing indicator to store if it is missing or not. Okay, for our MNAR dataset, so we could add it here using comma bracket add indicator equals to true to add an indicator in the column. Okay, so if you will run this, you will get an extra indicator as the column here. Okay, no extra code needed for adding extra indicator here. Okay, we could directly put inside your simple imputer. Now next we have is our outlier handling. Okay, so for our next code we basically use our df.describe, and here we basically see our 75%, our quartile and our max quartile. Okay, so if you'll see here, you could see clearly that the last column here have the highest jump here. Okay, it is going from 1008 to direct 800 here. So like if they are a huge max value, or they have like large standard deviation and gap between quartile 3 and max, or like if you could also use df.skew here, so like df.skew to see how much skewed the matrix is using your numeric only equals to true. And here if the value is more than 1, you would say that the outlier handling is needed here. Okay, so in the skewness, anything below 1 is not outlier. Okay, so an outlier is a data point which is very far away from the rest of the data. Okay, so why the outlier exists? It is because of the following errors. Is that first is that we have our data entry error, where basically we mistype values. For example, we have to write 99 and we have write 999, or we have like added a negative symbol etc. Okay, so by this our mistype value we could get an error. And then we also have measurement error like our sensory noise or our medical lab instrument etc. Then we could have our real rare events or our fluctuation like luxury house pricing, fraud transaction, or disease severity stroke. So we get an outliers here. So basically here these are not actually errors here. Okay, for our real rare events. So how should we handle? First thing you must ask is that was data an error or not here. Okay, so if it was an error, you could directly remove the rows here, or if it was not an error, you could then use capping here. Okay, so for our df dataset, I would check the extreme values here which have our more than 108. You would see here that it's a real value here. Okay, so if you will also go to 500 here, you would see that it's real value and the duration is actually increasing here. Okay, so I would say it was not an error here. Okay, we have like 14157 data sets here, so I would say it was not an error but an extreme case. So I'll be capping here by using numpy and np.clip here will be I'll be doing for duration, and here for lower I will be passing the lower value, and for higher I will be passing for 180. Okay, now when I will be describing, you would see here that max value is done here. Okay, so this is how you handle outliers. Now sixth point, we are to check whether we want to normalize or not. Okay, so for the normalize section here, you need to find that you are getting higher values here. Okay, so for age it is going from 18 to 60, and then for salary it is going from 10,000 to 6,000. So this is basically the scale where the value is increasing very rapid here. Okay, so if you'll be doing df.describe for our movie here, you could see here that minimum is 1, but the maximum is going from very high here. Okay, so we could then use our normalization here for our runtime here. Okay, so normalizing is basically rescaling our numerical feature to a common range or scale. Okay, we scale because we need it, not because our data have a problem here. Okay, many models like distance gradient, descent, dot product, SVM margins needs a scale data set here. Okay, if the features are not scaled, then model training become unstable, or the conversion becomes slow, or the one feature dominates here. Okay, it is mainly for our distance based model this problem come. Now for our normalization, we generally use standard scalar for all our normalization. Okay, but min max scalar is also used. So here we import from sklearn preprocessing, then we feed the transform our data set, and it is generally used for neural networks, and it is sensitive to outliers. Okay, for our standardization, we got here mean equals to 0 and standard deviation equals to 1. Okay, it was well for most model, but is less sensitive than min max. Okay, this is usually default choice for our model here. Then we have your robust scaling, so like it uses median and IQR. So like if you are not done outlier handling, you could use robust scaling. Okay, here is scale keeping in mind the outlier here. Okay, so we generally use our standard scalar. So we go back to our code and we run standard scalar here. Okay, so we import it from sklearn.preprocessing, then we define our standard scalar, and then we feed and transform to our data set here. Okay, data set it needs as in columns here, so I will type movie select d types exclude equals to object in category here, and then I will be passing it columns here. Okay, it's d types and it exclude here. So now you will be seeing that everything is standardized here. Okay, so this standard deviation now around 1 and mean is around 0 here. Okay, so then this is how we use standard deviation to solve our scaling problem, and this is basically how we use normalization, and we could use min max or robust here. Okay, so that's all for today. In this video we learn about how do we pre-process the data here. So we go from handle duplicates to handling imbalance to handling non-numeric type, then handling the null values, then finally handling the outliers, then how to feature scale, and finally we'll be doing feature engineering in our very next video. Okay, it is one of the most important topic, and it is one of the most longest topic in our data pre-processing. So in our next video we will be seeing everything. Okay, so in this video we learn about all about pre-processing. So that's all for today. Thank you and bye bye.